Okay, this is a pretty annoying assignment. The U.S. Mint charges $25 for each limited edition coin. There's a limit of 5 coins you can purchase. What's a reasonable domain and range of the function? Is it continuous or discrete? Alright, here's what domain and range means. Domain means all the possible x values, and the range means all the possible y values. And then I'll explain what continuous or discrete means once I find my domain and range. So you're going to make a table with dollars and coins. Now, if it's a money problem, have what you're buying is x, and money itself is always going to be y. Then per. Dollars per coin. Don't say we don't know it, because we do. Dollars per coin. That means when you buy one coin, what's the cost? How much does it cost? One coin. It's right there, $25. Okay? Now you can write times x if you want, but you're not making the line. What you want to make is a big long table. When you have to find the domain and range, you want to make a big long XY table. With x being, put your labels, coins, and dollars. And you're going to put 0. Now, if you buy 0 coins, how much money are you going to have to pay? 0. Okay? Now go 1, 2, and every time I buy a coin, I'm adding $25. So plus 25, that would be 25. Plus 25, that would be 50. Now, after that's done, I want you to identify a limit. Well, the limit is 5. It's 5 coins, so I want you to go above coins, and you're going to put limit equals 5. Okay? So we're going to stop making the table when we're at 5 coins. Okay, so 3, and I add 25, that's 75. And you're like, when do I stop? Well, when you're at 5. 4, I add 25, and that's going to be 100. Then plus 25, I'm at 5, and that's 125. Now you stop, okay, because you've reached your limit for coins. Limit's $5. Now the domain is all your possible x values, so you can buy between 0 and 5 coins. So you put 0, 5. You got brackets there. So the coins can go from 0 to 5. Now the range is your possible y's. Well, you can spend $0 to $125. So 0, 125. Now here's what continuous or discrete means. Okay? Basically, it means could decimals be included in the domain and range. So just go under domain, please, the x, and let's pick the same number every time. 1 and 2. Pick 1.5. Can you go to a store and buy 1.5 coins? Can you cut a coin in half? Probably you wouldn't. Okay. So you cross it out, and that means it's discrete. That means only the whole numbers would be applicable. Okay, there wouldn't be any decimals in between. Okay, next problem. You're buying party favors that cost $2.47 each. You can spend no more than $30 on party favors. What's a reasonable domain and range of this situation? Would the function be continuous or discrete? So you got party favors and dollars. Now once again, on a money problem, the thing you're buying is the x, and the money itself is the y, because it's dollars as a function of party favors. Y is always a function of x. So dollars per party favor. And don't say we don't know it, because we do. Dollars per party favor means how much does one party favor cost? Well, it's $2.47. Okay, you can put times x, but you're not making a line. To get to the domain and range, you make a big long table. And this one we're going to have to go a while. XY, dollars is y. The party favors would be the x. So put a 0. Now if you don't buy any party favors, you're not going to have to pay any money. Then when you buy 1, you're going to add $2.47. So that would be $2.47. And if you buy a second party favor, you're going to add 2.47. It's going to be 4.94. Now after you get through 2, you want to set your limit, okay? But put the limit on top. Now the limit would be how much money you have, which is $30, but now the limit's over here. Limit is $30. So the limit here is 30. Now the limit's over in the range, okay, not the domain. So you go until you cross $30. Either hit exactly 30 or go over it, okay? So, and you can organize it if you make lines. So a third party favor, I'd add 2.47. You want to go small here. Plus 2.47. $7.41. Okay, a fourth one, you'd add 247. This isn't very fun, I will admit it. $9.88. Buy a fifth party favor, you add 2.47. Gives you $12.35. A sixth one, add 2.47. 14.82. Now you're wondering, when do I stop? Well, when we get to our limit of $30, okay? 7, add 2.47. Domain and range has to have a limit and a word problem, and we know the limit, 17.29 plus 2.47. 19.76. 9, add 2.47. Going to be $22.23, $22.23. Then 10 plus 2.47. Give me 24.7, which is $24.70, not 7 cents. You put a 0 after it, plus 2.47. Okay, $27.17. Then 12 plus 2.47. Gives you $29.64. Now, I'm going to stop, and here's why. Because if you went to 13, 29.64 plus 2.47, that's 32. That's over the limit, so we can't make it to 13. Now we're good. So the domain, 0 to 12. Okay, that's your possible x values. The range is your y. Possible y values, 0 to $29.64. Now we have to decide if it's continuous or discrete. Put 1.5. Can you go to a store and buy 1.5 party favors? No, those come by the whole. Okay, so that again is discrete. Okay, next one. This is another crappy one. A car can travel 32 miles per gallon of gas. A car's tank holds 17 gallons. What's a reasonable domain and range for this situation? Is it continuous or discrete? So your units are miles and gallons. Now I have told you what x and y should be. Y should be miles, x should be gallons. And then per, it's always the y per x, miles per gallon. Now the miles per gallon is 32. 32 times x. That's going to be the rate of change. Then, big long table, x, y. X is your gallons, and y is your miles. So if I have 0 gallons of gas, I can't drive any miles. If I buy 1 gallon, If I have 1 gallon of gas, I would add 32. That's what miles per gallon means. Every 1 gallon, you get to add 32 miles on what you can drive. 32 plus 32 is 64. Now, after the 0, 1, 2 is done, set your limit. 17 is your limit, gallons. So limits over here, because gallons is over here, equals 17. So 3, this is going to take a while. 64 plus 32 is 96. 4. 94 plus 32 is going to be 128. Plus 32, that's going to be 160. You know you can stop when you've either reached 17 or go over it. 6, so plus 32, that's 192. 7 plus 32, make sure I get it right here, it's going to be 224. Just leave that on your calculator, don't clear it, because then you can just hit plus 32, 256. 9th gallon, plus 32 more miles, 288. 10 plus 32, 320. 11 plus 32, 352. Guys having fun yet? Plus 30, don't imagine you are. 384. 13 plus 32, we're getting close to 17. Plus 32, 488. Plus 32, 48, whoops, my bad, 488. Wait a second, 488's wrong, okay. That was 416 plus 32, sorry about that, 448, not 488. Wrote the wrong thing, plus 32, 480. 16 plus 32, 512. 17 plus 32, 544, and I don't want to go past 17 because that's your limit. So the domain 0 to 17. Remember, the domain is your possible x's, the range is your possible y's. 0 to 544 is the y. Now, this is going to be an example of a continuous, because if you put 1.5, you can buy 1.5 gallons. You can pump 1.5 gallons of gas, okay? So I don't cross it out, I circle it. That means decimals in between the numbers would be included, so that is continuous, okay? Okay, last problem. I'm going to cross out the $50 and I'm going to put $15. You have $15 to spend on packages of Halloween candy. Each bag of candy costs $4.99. What is a reasonable domain range of the function? Is it continuous or discrete? So, you got packages and money. Money was in bold. So, X is the packages, Y is the money. So dollars per package. Every time you buy a package, it costs $4.99, so that's your rate of change. Now, a domain and range, I'm not looking to make a line, okay? I want a table. So Y is the money, X is the packages. Now I'm going to go 0, 1, 2. So if I don't buy a single package, I'm not going to have to pay any money, but when I start buying the packages, I add the $4.99. So $4.99, 4.99 plus 4.99 is going to be 9.98. Now set in your limit. Well, you only have $15, so the limit's over here. On the money side, it's $15. So I want to stop when I cross over $15. So I'm going to go to a third package plus 4.99. Okay, 14.97. Okay, now if I buy a fourth package, I don't think I can buy a fourth package because if I add $14.99 or $4.99, I'm going to be over my limit. Yeah, can't happen, so get that out of there. So domain 0 to 3, that one didn't take as long because I was nice and lowered the limit. And then 0 to 1497, comma 14.97. Now is this continuous or discrete? Can you buy 1.5 packages at a store? No, you have to buy them by the full, so that doesn't make any sense. So it'll only be the full amounts. That means if I graphed these, made these points on a graph, they would not be connected. Okay, so it is discrete. On the third example with the gallons, I would have connected them because decimals can be included.